This presentation is a project for sound analysis and recommendation. The content of this presentation include the introduction of sound data resource, data analysis and insights, and finally, the recommendation models. First, I want to introduce you where we get our data sets. So we have two major data sets. One is a million sound data subset that contains 10,001 sound records. This dataset contains 29 sound features. 7 of them are categorical and 22 are numerical. We did some analysis and exploration on those features. And the second dataset is a user dataset that contains 48 million, more than 48 million records. Those are just the play count of one user corresponding to one song. So there are a lot of them. One interesting correlation we uncovered is the hotness of the song, meaning the popularity of the song, and with the artist familiarity. So there is a high positive correlation between them because if an artist is more popular, then people are more likely to listen to their music and vice versa. We also visualize the artist's location on an interactive map. Here, we just included a screenshot here. We included a label for each data point on the map, and you can see the label include the artist's name and the corresponding location. We also visualizes the song released by year. In this specific data set, we can see that the majority of the songs are released after 1990, and a lot of songs are released after 2000. There are some interesting data insights we can derive from the song data set. I want to understand whether there is a trend or changes in sound genres throughout the year. So I tested it out with 3 data points. So this function takes in the data set, the year, and returns the number of songs that ranked by hotness. So as we can see here, if you have some background knowledge, you know that in 1980s, there are classic rock bands that are the most popular during that time. And then in early 2000, pop singers are really popular. And then towards 2010, they are rising rap artists. So the rest of the presentation will focus on the recommendation models. We have built 3 models. The first one is based on artists. We created this simple data set that merged 2 data sets together. We have the user, song ID, count, artist name, hotness, and title. The idea of this model is if one person likes a song and that person is likely to like other songs released by the same artist. So we gave this function a song input and it grabs the other songs released by the same artist, ranked by the play count, and then give you 5 songs that are the most popular ones released by the same artist. So the example here is if I give an input song called Crazy, it will give you other songs played by the same artist, Eurythmics, and 5 other songs by this artist. The second recommendation model is based on song/item similarity. We pivoted the data set to each row represents a song record and each column represents a user record. The value is their play count. We created a function that recommends songs based on the similarity between the songs themselves. We used KNN model, and the metrics we use is cosine metrics. It measures the similarity between songs and produce the output is a song title, artist, and the distance. Example here is if I give an input of the song called Don't Panic, it will return the song's name, the input song's name, and other songs it recommend you. Here, the Don't Panic is played by Coldplay, and other recommended songs, we can see 3 of them are also played by Coldplay. So it makes sense because the songs that are released by the same artist are likely to be similar. So the distance are ranked from the least amount of distance to the most. The last and the least model is based on user similarity. This is a collaborative filtering based on user similarity instead of the songs. And in this, for this model, we pivot the data frame differently. We have each row represents a unique user, and each column represents a song. We use 2 different similarity measurements for my model. So the first one, we use the traditional cosine similarity, and then we experimented with Jacquard similarity. We created a function here. The idea is the function will take input of a user, the model that we used, whether if we use the KNN model with different similarity measurements, and then we'll give the number of songs we want recommended. The function will calculate the similar users that's similar to the user you're given to this function, and then it will grab all the songs played by the user, kind of add the songs one by one to a set we create, and then it will return the top 5 songs or the number of songs you wanted to output. So the example here is I randomly picked a user that this is an unseen data point, and I feed it into the function model. It produced 5 sounds that the similar user listened to, and it's included here. So to test the accuracy of the function, we created this hit rate measurement that it counts the songs that they recommend and how many of them are actually listened by the test user, and then divided that number by the total recommended songs. The last page is running the evaluation model and compare the 2 distance measurements. One is cosine, one is Jacquard, and it turns out that for the one on the left is cosine. It have the total average hit rate of 48% for the 10 users. And then the one on the rest gives the average hit rate of 66% for the 10 users. It looks like the Jaccard measurement is a little more accurate in general, and the model is also faster too. So it's the preferred better model for in this project. That is all. Thank you for watching.